Hello, today we are going to start the new chapter, that is heights and distances. In this chapter, we are not going to have many synopsis points or important points, but you must learn a few things. You must remember a few things. What is angle of elevation? Suppose this is the ground and you are standing here and looking up at some object. Then this angle formed with the ground, that is called angle of elevation. But then there is a second thing which you have to remember, that is angle of depression. What is angle of depression? Suppose this is the eye level. You are standing on a building and this is your eye level. You are standing here. And suppose you are looking down at some object you are looking down. So the angle formed with your eye level, that is called angle of depression. Now, the next thing you have to remember is in a triangle. Let us name the triangle ABC. The internal bisector of an angle. For this angle, we will take internal angle bisector. This angle bisector divides the opposite side in some ratio. What is the ratio? The ratio will be the opposite sides which form the angle. That means BD is to DC will be equal to, if you take AB's measure as C and AC's measure as B, so it will be C is to B. So you can say that the internal bisector, angle bisector of angle A divides the opposite sides in the ratio of the sides which form the angle. C is to B is the ratio. Okay, so this is third point. Now fourth point is, if you take an isosceles triangle, ABC is an isosceles triangle. The median will be perpendicular to the base. Median means take the midpoint D, join A and D. This is the median. The median will be always perpendicular to the base. And according to the theorem called MN theorem, BD is to DC. The ratio will be M by N. Then you can say that M plus N cot of angle theta will be equal to M cot of alpha, this is alpha, minus N cot of this angle is beta. Similarly, M plus N cot theta will be equal to N cot B minus M cot C. Next, fifth important thing is, in a circle, if you take a chord AB, this chord AB subtends an angle on the circle, like angle ABC. If this is theta, the same chord AB subtends another angle D on the circle. This also will be theta. The same chord AB subtends another angle on the circle E. This also will be theta. So angles in the same segment of a circle will be equal. Segment in the sense the chord divides the circle into two segments. This complete thing come under one segment, major segment, and this complete thing comes under minor segment. So angles in the same segment are equal. That is what we can see. These all theorems you have already learned in geometry, but we are repeating again. For instance, in a circle, I will take the chord A. This chord AB subtends an angle AOB at the center and an angle APB on the circle. If angle APB is theta, then the angle subtended at the center will be 2 theta. That means the double. Okay, next. Seventh point is, suppose there is a plane. Any line which is perpendicular to the plane, it is perpendicular to every line on that plane. Suppose there are many lines on the plane. To every line, this line will be the perpendicular line. Next is, in a triangle ABC, you extend the side BC to D. This is exterior angle theta. And the opposite interior angles are alpha and beta. So exterior angle will be equal to sum of opposite interior angles in any triangle. Similarly, one more point, a few points are there. In a right angle triangle ABC, if you take the midpoint D on the hypotenuse, this D is the midpoint of the hypotenuse, then the distance from D from the vertex A, distance from D from vertex B, distance D from the vertex C will be equal. DA will be equal to DB will be equal to DC. Next, 10th point is, in any triangle, not as such any special triangle, in any triangle ABC, if D is the midpoint of the side BC, then we can say that AB square plus AC square will be equal to 2 times AD square plus DB square. Okay. The next is, we will learn something called bearing of a line. What is bearing of a line? This point I will write point 11. Suppose there is a horizontal line. So the bearing of a horizontal line or a horizontal plane, we can take a horizontal plane also and find the bearing of this horizontal plane. So what is the bearing? It is the positive acute angle made by this line with the north-south line in the same plane. So if this line makes an angle with acute angle with the north-south line in the same horizontal plane. Suppose this is north and this is south. this is the north-south lane. So the acute angle formed by this line, that is called bearing of the line. Similarly, suppose this is north and this is south in the horizontal plane. So this acute angle made by the plane is called the bearing of the plane. When you learn about examples, you will come to know what is bearing of a plane. Let us go to questions now. The first question says, the shadow of the tower standing on a level ground is found to be 60 meters longer when okay longer when the sun's altitude is 30 degrees than when it is 45 degrees. You have to find height of the tower. So imagine this is the tower which is standing on a level ground. We don't know height of the tower, we will take h. Now suppose the sun is here. At this altitude, that means when it is 45 degrees, the angle of elevation of the sun is 45 degrees here. After some time, if the sun moves here, then the angle of elevation of the sun will be 30 degrees. So here initially when the angle of elevation was 45 degrees, this is the shadow's length. But when the angle of elevation is 30 degrees, this is the shadow's length, which is 60 meters longer. That means this is 60 meters. So clearly what is said in the question? The shadow of the tower standing on the level ground is found to be 60 meters longer when the sun's altitude is 30 degrees than when it is 45 degrees. With this example, with this information, we have to find the height of the tower. So suppose if I take this distance as x, so I can say tan 45 degrees will be equal to h by x. 45 degrees is 1. So 1 is equal to h by x or h equal to x. So next we will take tan 30 degrees, which is h by x plus 60. Tan 30 degrees is 1 by root 3 and in place of x we can write h because we have to find height of the tower h. So h plus 60 equal to h root 3. H root 3 minus h is equal to 60 or h into root 3 minus 1 is equal to 60. H is equal to 60 by root 3 minus 1. You can rationalize by multiplying root 3 plus 1 up and down. So you have 60 into root 3 plus 1 by 3 minus 1, that is 2. Or the final answer is 30 into root 3 plus 1 meters. which is there in the option. Let's go to the second question. From the top of a hill, 300 meters high, the top of a tower was observed at an angle of depression 30 degrees, and from the foot of the tower, the top of the hill was observed at an angle of elevation 45 degrees. The height of the tower is. So first of all, it is clear that the hill is taller than the tower. This is hill and this is tower. Why am I saying hill is taller than the tower? What did they say? From the top of the cliff, from here, which is 300 meters high, if you look at the top of the tower, then the angle of depression is 30 degrees. Now from the foot of the tower, from here, the top of the hill, I will draw again. So from the top, from the foot of the tower, the top of the hill is observed and angle of elevation is 45 degrees. That means this angle is also 45 degrees. We have to find height of the tower. So I will draw a line parallel to the ground, because this angle I can take as 30 degrees. This is h. So the upper part will be 300 minus h. Now, suppose this I will take it as d. I can write tan 30 degrees is equal to 300 minus h by d. Similarly, tan 45 degrees, this will be d. Tan 45 degrees can be written as 300 by d. Because tan 45 is 1, we can say d will be 300. And so here, tan 30 1 by root 3 equal to 300 minus h by d is 300. 300 equal to 300 root 3 minus h root 3. So h root 3 will be equal to 300 root 3 minus 300. Or h is equal to 300 common root 3 minus 1 by root 3. So you can rationalize this by multiplying root 3 up and root 3 down. So you have 300 into 3 minus root 3 by 3, or 100, because in the options you are given 100 into 3 minus root 3 meters. That is the height of the tower. Okay, question number 3. The angles of elevation of the top of a tower at the top and foot of a pole of height 10 meters are 30 degrees and 60 degrees respectively. The height of the tower is. So obviously the pole is less taller than the tower. How? I will tell you. Suppose this is the tower and this is pole. The pole is 10 meters high. This is ground. Why did I say tower is taller? Because we are observing from the top of the pole the top of the tower. From the foot of the pole also we are observing the top of the tower. See, the angle of elevation of the top of the tower at the top and foot of the pole of height 10 meters are 30 degrees and 60 degrees. We have to find the height of the tower. So this is 10 and the upper part will be h minus 10. So if you take this distance as x and x, from the upper triangle, tan 30 degrees is h minus 10 by x. From the lower triangle, tan 60 degrees is h by x. You can divide these two so that x will cancel. Tan 30 is 1 by root 3 and tan 60 is root 3 equal to h minus 10 by h. H is equal to 3h minus 30. 2h is equal to 30 or h will be 15 meters. The height of the tower will be 15 meters. Okay, next we will go to question number 4. A person standing on the bank of a river observes that the angle subtended by a tree on the opposite bank is 60 degrees. When he retreats 20 meters from the bank, he finds the angle to be 30 degrees. The height of the tree and the breadth of the river we have to find. So imagine this is the river. A person is standing here on the bank. The river is like this. Now you may not understand, but if I draw, the river is like this. Okay. So a person is standing on the bank of a river and observes the angle subtended by a tree on the opposite bank is 60 degrees. Okay. So there is a tree on the opposite bank. This tree subtends an angle 60 degrees here. The tree is on the opposite bank. Now he retreats 20 meters. He go back 20 meters. Now he finds that the tree subtends the angle 30 degrees now. We have to find height of the river, I mean height of the tree and breadth of the river. Height of the tree and breadth of the river. Both we have to find. So from one triangle, tan 60 degrees is H by B. From other triangle, tan 30 degrees is H by B plus 20. If you divide, H will cancel. Tan 60 is root 3, tan 30 is 1 by root 3 is equal to B plus 20 by B. Or you can see 3 equal to B plus 20 by B, 3B equal to B plus 20, 2B equal to 20, or breadth of the river is 10 meters. Once you get the breadth, you can take tan 60 degrees is equal to H by B. Tan 60 is root 3. Height of the tree is H. Breadth of the river is 10. So height of the tree is 10 root 3 meters. Let's go to question number 5. An observer on the top of a cliff 200 meters above the sea level observes the angles of depression of two ships on the opposite sides of the cliff to be 45 degrees and 30 degrees. The distance between the ships, if the line joining them points to be the base of the cliff. So suppose this is the top of the cliff. This is the height of the cliff. The height of the cliff is 200 meters above sea level. So the observer is standing on the top of the cliff. Now he observes two ships on the opposite sides of the cliff. When he observes the first ship, the angle of depression is 45 degrees. So this is the sea level. That means this angle also will be 45 degrees. Now when he observes the other ship here, that time the angle of elevation is 30 degrees. That means this angle will be 30 degrees. We will take this distance as x and this distance as y. Now you have to find the distance between the two ships. So from one triangle, tan 45 degrees is 200 by x. Because tan 45 degrees is 1, you can say x will be 200 meters. So here we got 200 meters. From the other triangle, tan 30 degrees is 200 by y. Tan 30 degrees is 1 by root 3 equal to 200 by y, or y will be equal to 200 root 3 meters. 200 root 3 meters. So the distance between the ships D will be 200 plus 200 root 3, or 200 common 1 plus root 3 meters. Let us take the sixth question. The sixth question says, at the foot of a mountain, the elevation of its summit, the elevation of its summit is 45 degrees. After ascending 1000 meters towards the mountain, up a slope of 30 degrees inclination, the elevation is found to be 60 degrees. The height of the mountain is, suppose this is the mountain, and the height of the mountain we have to find h. Now what is happening is, a person is here and this is the slope of the mountain which is making 30 degrees with the ground. So the person walks through a distance, but in the beginning, when the person is standing here, he looked at the summit of the mountain, the top of the mountain, and he got angle of elevation of the top of the mountain as 45 degrees. Then he walks on this slope for 1000 meters, and then he stands here. This is his level. This time, when he looks at the top of the mountain, he finds that angle of elevation is 60 degrees. With the help of all these, you have to find the height of the mountain. H you have to find. So what I will do is, I will take this small angle as 15 degrees. Now, we will draw a line here, and we will name it as something like X. So first, what I can do, I can find sine 30 degrees. Sine 30 degrees is opposite side by hypotenuse. Sine 30 degrees is 1 by 2 equal to x by 1000. So x will be 500 meters. Or you can say half kilometer also. 500 meters means half kilometer. Now I can say, if x is 500 meters, this will be also 500 meters. Isn't it? This distance which I am writing will be 500 meters. And now this upper part will be h minus 500 meters. So now I will take same triangle cos 30 degrees. So this I will take as y. This means this distance. If I take cos 30 degrees, it will be y by 1000. Cos 30 degrees is root 3 by 2 equal to y by 1000. Or y will be equal to 1000 root 3 by 2, or y will be 500 root 3 meters. So we know what is x, what is y. Okay. Now, in order to find height, what we will take? We will take tan 60 degrees. But before that, I want to use a different color and write something here. Green color. If you take tan 45 degrees, what is tan 45 degrees? H by this entire thing. Let it be Z. H by Z. Because tan 45 degrees is 1, H by Z is 1, or H will be equal to Z. So Z means nothing but H. And Y already we got 500 root 3. So this part will be H minus 500 root 3. Or I can say this part also will be H minus 500 root 3. Now, as I said, I will take tan 60 degrees. What is tan 60 degrees? H minus 500 by H minus 500 root 3. Because tan 60 degrees is root 3 equal to H minus 500 by H minus 500 root 3. We can write H root 3 minus 1500 equal to H minus 500. Or H root 3 minus H equal to 1500 minus 500. Or H into root 3 minus 1 equal to 1000. Or H will be equal to 1000 by root 3 minus 1. You can rationalize root 3 plus 1, up and down you multiply. So H will be 1000 into root 3 plus 1 by 2, or 500. Height of the hill will be 500 into root 3 plus 1 meters. This is how we can find the height of the hill. See, we did many things here. What are the many things? I want to show with the arrow, or I will use highlighter. First, I used the small triangle, this small triangle with 30 degrees angle. I took sine 30 degrees as x by 1000. Because sine 30 degrees is 1 by 2, x by 1000, x will be 500. So x I got 500. So this opposite side also will be 500 and the upper part will be h minus 500. Similarly, I took cos 30 degrees. It is y by 1000. So cos 30 degrees is root 3 by 2. So y I will get 500 root 3. If y is 500 root 3, now I will take the larger triangle 45 degrees angle, because tan 45 degrees is h by z. So h will be equal to z. Coming to tan 60 degrees, it will be h minus 500 by h minus 500 root 3. So tan 60 degrees is root 3. So h root 3 minus 500 into 3, 1500 equal to h minus 500. H root 3 minus h will be 1500 minus 500. That is 1000. So in this way you can find the height of the hill or mountain. Next we will go to question number 7. In this question number 7, the angle of elevation of the top of a tower from a point A due south of the tower be alpha, and from B due east of the tower is beta. If AB equal to D, height of the tower is. So first of all, this is the tower. Right? Height of the tower we don't know, we have to find. On the south, there is a point A. From A, you are seeing the top of the tower. The angle of elevation is alpha. And on the east, there is a point B. This is the ground level. From B, you are seeing the top of the tower again. This time, angle of elevation is beta. The distance AB is D. From all these, you have to find height of the tower. So first of all, I will take tan alpha. Suppose if this distance, I will take OA as x. So tan alpha is h by x, or x can be written as h by tan alpha or h cot alpha. X will be equal to h cot alpha. This is what we know. Next, in the same way, tan beta. This distance OB, we will take it as y. So tan beta is h by y, or y will be equal to h by tan beta equal to h cot beta. So we just got x and y, but we have to find height of the tower. Now, because this angle will be 90 degrees, this is east, this is south, angle will be 90 degrees. So you can use Pythagorean rule, that is d square equal to x square plus y square. Or d will be square root of h square cot square alpha plus h square cot square beta. They are asking us to find height of the tower. So instead of taking square root, it is better if we remove the square root, because we want height of the tower. So d square I will write. Take h square common, cot square alpha plus cot square beta equal to d square. H will be square root of d square by cot square alpha plus cot square beta. That's it. This is what we have to find. Eighth example. A spherical balloon whose radius is r centimeters subtends at an observer's eye. Subtends at an observer's eye an angle alpha. When an angular deviation of the center is beta, the height of the center of the balloon. The height of center of the balloon they are asking. So suppose, imagine this is the balloon, this is the center of the balloon, and this is ground. So they are asking you this height. Height is, everywhere we have to take centimeters, because r is given in centimeters. So h also I will take in centimeters. The height of center of the balloon is h meters, which we have to find. Okay, the radius of the balloon is r. The radius of the balloon is r. So what did they say? A spherical balloon whose radius is r subtends at an observer's eye an angle alpha. So this is the person, this is the observer, where this diamond forms, makes an angle alpha. That is what they are saying. A spherical balloon subtends an angle alpha at the observer's eye. When the angular deviation of the center is beta, suppose angular deviation, that means this. So when an angular deviation of the center is beta, the height h we have to find. That is all given in the question. Now we can take CA equal to R, CB equal to R. Now, if I join to the center, this angle will be alpha by 2 and this angle will be alpha by 2. It is the angular bisector. Now I will find what is sine alpha. Or first I will find what is sine alpha by 2. I'll take this triangle and find sine alpha by 2. Sine alpha by 2 will be R by H. Or instead of this, what I can write is sine alpha by 2 is R by, suppose if I take O, here, R by OC. Or OC is R cosecant alpha by 2. This is what we got one information. Similarly, because angular deviation of the center is beta, angular deviation of the center is beta. So now I will take sine beta. What is sine beta? This I have to take Cm. Sine beta is Cm by OC. Isn't it? Or Cm will be equal to OC sine beta. Cm is nothing but height of the balloon. And OC is R cosecant alpha by 2 sine beta. This is how we get height of the center of the balloon, H. We can do one more problem quickly. I thought we have to do 9, 10 problems, but we are doing only 9. Let us quickly finish it. The angles of elevation of the top of the tower from 2 points distant A and B from the base and in the same straight line with it are complementary. Then find height of the tower and if theta is angle subtended at the top of the tower, at the top of the tower by the line joining these points, by the line joining these points, then sine theta also you have to find. So first of all, this is the tower. The height of the tower we have to find, so we will take h. This is ground. Now there are 2 points A and B. A is at a distance A from the tower. B is at a distance B from the tower. Now from A, you are watching the top of the tower. This is angle of elevation alpha. From B, again you are watching the top of the tower. It will be 90 minus alpha because these two angles are complementary. That is what they said. So based on this information, tan alpha can be written as h by A. And tan 90 minus alpha can be written as h by B. Or cot alpha is h by B. Now, if you multiply these two equations, tan alpha into cot alpha equal to h square by AB, I will get. Or I can write 1 is equal to h square by AB, or h square equal to AB, or h is equal to root of AB. The first part we have found. Now, what is the second part of the question? That also we will find. Theta is the angle subtended at the top of the tower by the line joining these points. So this line makes or subtends an angle theta at the top of the tower. That is what they have given. So now, because h we got as root AB, I will take tan alpha again from the triangle. Let us see the triangle. Tan alpha is h by A. So tan alpha is h by A. A tan, or I'll write A down only, not to worry. So I will write tan alpha equal to h is root AB by A. Or tan alpha is root B by root A equal to root of B by A. Now, because exterior angle is equal to sum of opposite interior angles, I can write 2 alpha equal to 90 plus theta. Cos 2 alpha will be cos 90 plus theta. Or cos 2 alpha is minus sine theta. Sine theta is minus cos 2 alpha. Or sine theta is minus cos 2 alpha is 1 minus tan square alpha by 1 plus tan square alpha. We know what is tan square alpha. 1 minus b by a by 1 plus b by a. That is minus a minus b by a plus b. Or sine theta can be written as b minus a by a plus b. This is what they are asking. So next class we will do some more problems. Prepare well and come, because we have to end the session now.